Hello and welcome to another video. In this video, we're going to be working on binary tree in-order traversal. And in the problem, given the root of a binary tree, return the in-order traversal of the node's values. So we have these examples. So in this example, it should be 1, 3, 2. And in the second example, it's empty. And the third example, it's 1. So the real question is, what is an in-order traversal? So there's three types of traversals you want to know. It's pre-order, in-order, and post-order. Pre-order means you visit the left node, then the root, then the right node. In-order means you visit the left node. So actually, pre-order is a little wrong here. So it's root, then left, then right. And in-order is left, root, right. And post-order is left, right, root. So these are the main ones you want to know and you want to memorize them. And essentially, to code this up, so this is kind of what we want to do. So let's maybe make a tree here, and we can use that as an example. So we can look at let's make a tree like this. So let's say we have this tree with some values, and we can go over like what a in-order traversal would look like here. So let's give it some values like 1, 2. So just pencil them in 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So in in-order traversal, remember we go left, root, right. So let's take a look at how we would visit them. So we would start at the root, and then we'll have like our output array of what it should look like. So we start at the root, and we go left first. So we can keep going left until there is no more left. So this is the one we're going to visit first. So we'll visit 1, recurse back up, then get the root value. So 9, then go to the right node. So 2, then recurse back up to the 9 and recurse back up to 13. Then we go right, then we go left as much as we can. So we're going to go to 3, recurse back up, 10, go down here, 4, recurse back up to 10, recurse back up to 13. Now we're done with this whole side. Now we go to 14, then we go left as much as we can. This is the kind of for this traversal, you always just go left as much as you can. So we go left over here, then we have 5, go back up here, 11, go right, 6, recurse, and then go left as much as we can, 7, go back here, 12, and 8. And the idea is, if this was actually a binary tree, a binary search tree, where every left node was less than the root and every right node was bigger than the root, if you do an in-order traversal, it will actually give you all of your values in like a sorted order. So it'll give you like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. But the easiest way to do this, so for all these traversals, all we need is one recursive function, and it's going to have 3 lines of code, and we just swap it depending on which traversal we need. So it's going to have 3 lines of code. So we will have one line will be traverse left. One line will be take in the node's value. And the other line will be traverse right. And so depending on which one we want, we can just swap these around. So if we want to do a pre-order traversal, if we want to go root left right, the root is the value we're taking in. So then we would do this line first. Then we would do this line second, then we would do this line third. If we want to do an in order where we want to go left, root, right, we would keep it just like this. So left, root, right. And if we want to do a post order, it's going to go left, right, root. So literally all your traversals are going to have a recursive function with these 3 lines. And then we just need to remember which one are we using and what's the order. And so it's super easy. So we can code it up. So we're going to have a result array, and we're just going to have these 3 things, right? So we'll define a function here, and so the function is going to be called like traverse. It'll take in a node, and then we can say if not node. So this is the other one. You just want to return if the node is empty, but everything else is just these 3 lines of code, right? So if we want the in order, we're going to have left, root, right. So we're going to say traverse node.left, then take in the current value, so res.append node.val, and then traverse right. And that's literally all we need to do. And then we just need to call the function and return our result. So we can call traverse starting at the root and return the result. And if you want the other traversals, all you have to do is swap the order of these lines around, and that can give you all of your traversals. So let's try to run this. And there we go. And it's pretty efficient. You can also do this with a stack or some other stuff, but I think recursive is the easiest by far, so I'll just stick with that. And for every tree traversal, it's always O of n time, because you traverse every node, and O of n space, because your tree can be completely unbalanced. So if every node only had a right child, let's say, then you would have a recursive stack depth of your entire tree. So pretty much almost all DFS traversals will have this time and space complexity. And yeah, it's going to be all for this one. So hopefully kind of easy. Swap these around for whatever you need. And this is a very good template for, things that you need to do with a tree. So if you need to traverse and do other stuff, this is how you would do it. And yeah, that's going to be all for this one. So if you did like this video, please like it, and thanks for watching.